a second. Okay. So if any of you can't see the screen at any point, just let me know. I normally have the lights completely off, but I'm trying it this way first. So we're going to go ahead and start with factoring special cases. So these are trinomials that we may or may not have really worked with before, or they might be a special kind that have a different rule that applies to them. So this is going to be part 1 of 2. We're going to do this today, and we're going to do it tomorrow. Okay? This homework, though, is posted. It won't be due tomorrow, but it will be due the day after. Okay? So I am hoping that you're going to go ahead and get started with it tonight. We'll do roughly half the notes, and then I'll give you some time to ask questions. Okay? So this is just called factoring special cases. Can you all see that okay? Will anybody tell me if you can't see it okay? Hopefully. Okay. This will be obviously like put on Canvas for you to look at as well. There is already a video lesson up, but it's not one of me in front of you. It's just one that's up. Okay? Okay, so first we're going to start with perfect square trinomials. So perfect square trinomials are unique in the fact that the first term and the third term are both perfect squares. So a perfect square means the same number or value times itself equals that number. So for x squared, goodness, I can't spell and type or write at the same time. So x squared breaks down into x times x, which is the same value times itself equals that. 9 is 3 times 3. Again, a perfect square because 3 and 3 are the same number. Multiply them together and they give you 9. So a perfect square trinomial has a first term that is a perfect square and a third term that is a perfect square. It's also important to note that that middle term is 2 times my constant's perfect square, or square root, sorry, with that first variable on it. So 3 plus 3 is 6, and have an x to get the middle term. We already know that if I have a perfect square trinomial, it's going to factor into the square root of my first term and the square root of my third term with the sign of my middle term. So x squared plus 6x plus 9 factors into x plus 3 and x plus 3. X and x, because they multiply together to get x squared. 3 and 3, because they multiply together to get 9. And then it's plus in the middle because it's a plus 6x right there. The same thing would apply if this were a subtraction problem. So if I had a perfect square, such as x squared minus 12x plus 36, this would factor the same way the previous one did, except my operation in the middle is going to be subtraction because my middle term in the trinomial is a negative. Okay, so x times x gives me x squared, and 6 times 6 gives me 36. So my two factors are going to have an x and a 6 in them, and they're both going to be subtraction since that middle term is subtraction. The really cool thing about perfect square trinomials is that since they factor into the same factor twice, we can just write it as that factor squared. So here I could just write it as x minus 6 all squared. There are a couple characteristics of a perfect square trinomial that we always need to check before we apply this rule. It must have exactly 3 terms to it. third term must be perfect squares. The perfect squares must be positive. So this wouldn't work if my last value was a minus 36, because no number times itself is ever going to equal a negative. So the perfect squares must be positive. And the x term, so the middle term, must be 2 times the product of the roots of the perfect squares. Give you guys a second to write those. If you want to write them, you obviously don't have to. They are in the notes. If at any point you need me to slow down or anything, just speak up, okay? So if you notice, all of these things apply when we were looking at this x squared minus 12x plus 36. It has 3 terms, 1, 2, and 3. The first term and the third term were both perfect squares, because x squared is the product of x times x, and 36 is the product of 6 times 6. The perfect squares must be positive. Well, x squared is positive and 36 is positive, so that applied. And the middle term, so this negative 12x right here, we really just focus on the number of the variable, so 12x, must be 2 times the product of the roots of the perfect squares. So the root of x squared was x. The root of 36 is 6. 6 times x is just 6x. If I take that and multiply it by 2, guess what? I get 12x, which match the middle term that I had in that trinomial. Okay, so that one was in fact a perfect square trinomial. It has to fit all of these characteristics in order to be considered that. We like perfect square trinomials, remember, because they factor beautifully into the root of the first term and the root of the third term with the sign of the second term. Okay, so x squared minus 12x plus 36 factored into x minus 6 times x minus 6, which we just wrote as x minus 6 squared. So let's go ahead and do a couple more just as practice. So the next example I'd like to do is 9x squared minus 6x plus 1. The first thing we need to do is make sure this is in fact a perfect square trinomial. So I need to figure out what multiplies together to get 9x squared. Well, that's pretty clearly going to be 3x times 3x. So that one is a perfect square. What multiplies together to get 1? Well, 1 and 1. So that third term is also a perfect square. So far, so good. They're both positive numbers. The 9 is positive and the 1 is positive. So the last thing I need to check is that that middle term is going to be twice the product of my 2 roots. Okay, so 3x times 1 is 3x. If I double 3x, it turns into 6x, which is in fact that middle term right there, which means I can go ahead and factor this. So when I factor it, remember, it's going to factor into the root of the first term and the root of the third term with the sign of the middle term, so minus. And then we would just write it as squared because it's 3x minus 1 times 3x minus 1. Is that maybe starting to make sense for some of you?
Hey, I got a quick question.
Yeah, what's your question?
So for like to figure out for the middle term, you just need to You just need to times the root of both the the first and the last, and then once you have that, you times it by 2. And then
Yes,
if it gets the same number, not necessarily but it doesn't have to be like negative, or it doesn't
correct.
have to be
Just
the
the
exact.
number.
Doesn't have to have the same sign, but it has to be the same number. But if it's the same number, then it works, right?
Correct. Yes.
Okay, and then what is it? Our answer would be 3x minus 1
Squared.
squared.
Yes.
Okay, I
Because
want
this
to make
is a
sure about
factor.
that. Thank you very much.
You're welcome. We're going to go ahead and do another one. Actually, we're going to do several because, you can never have too much practice. So the next one that we should do is going to be x squared plus 2x plus 1. Just like before, we need to ensure that this is in fact a perfect square trinomial. I know it's a trinomial because it has 3 terms. So I'm going to go ahead and break down my first term and my third term. My first term is x times x, so that's a perfect square. My third term is 1 times 1, so that's a perfect square. I need to test that my middle term is twice their product. So I'm going to take an x and a 1 and I multiply them together and it gives me x. I do 2 times x, and I do in fact get the 2x that is my middle term. So far this satisfies all of my perfect square trinomial requirements, which means I can go ahead and factor this. Because it is a perfect square trinomial, it's going to factor into the same factor twice, which I just go ahead and write as that factor squared. The first term in my factor is the root of the first term in my trinomial. The second term in my factor is the root of the third term in my trinomial. And then the sign of my factor is the sign from the second term in my trinomial. So this factors into x plus 1 squared, which is the same as x plus 1 times x plus 1. Leaving that up, we're going to go ahead and do another one over here. This time I'd like to do 4x squared plus 12x plus 9. We're going to go ahead and run through the same system that we had before. So I need to factor the first term and factor the third term. 4x squared, well, to get what that is equal to, I need to take the factors of 4, and then I'll take the factors of x squared. To get 4, I have 2 times 2. To get x squared, I have x times x. So to get 4x squared, I have 2x times 2x. My third term is pretty easy because we know it takes 3 times 3 to get to 9. When I go ahead and put 2x times 3 together, I get 6x. And when I double it, that gives me 12x, which matches the middle term of my trinomial, so I'm good to go there. So from here, I just need to factor. So it's going to be the root of my first term and the root of my third term with the sign of my middle term. So this factors into 2x plus 3 squared. Questions, concerns, or issues so far? If not, we're going to go ahead and do just 2 more examples, and then we're going to move into our second special case, which will be the last one that we do today. Okay? Again, I'm going to post this video on Canvas, so if you have questions later on, just let me know. The next example I would like to do is actually one that I want you to do on your own. So I have x squared minus 4x plus 4, and I would like you to factor that. First, you need to verify that it is in fact a perfect square trinomial, and then you need to tell me what the factor is. I'll go ahead and give you 2 minutes. Okay, so hopefully, as you were working through this, you factored x squared into x times x, and you factored 4 into 2 times 2. Then you took one of each of these factors and multiplied them together, and then doubled it to verify that it did in fact match my middle term. It does, so this is a perfect square trinomial because the first and third terms are perfect squares. There are 3 terms. Each of my perfect squares is positive, and the middle term is twice the product of the roots of my square roots, or perfect squares, sorry. So from here I can go ahead and factor, and this should factor into x minus 2 squared, because x is the root of my first term, and 2 is the root of my third term, and then my middle term is negative, so that means that I have a subtraction sign in my root. So hopefully all of you got x minus 2 squared. If you didn't, can you tell me right now? Anybody want to own up? Okay, so I'm going to assume that we all did wonderful and perfect and you had no issues with that. Okay, so then I have one more question for you. And this is a very good test question to ask. So let's make sure we take note of it. So the question is, which of the following are perfect square trinomials? So you've got 4 options. We have A, which is 25x squared minus 10x plus 1. We have B, which is x squared plus 5x plus 4. We have C, which is negative 9x squared plus 12x plus 4. And then we've got D, which is x squared plus 14x plus 49. So remember, for it to be a perfect square trinomial, there are a couple requirements that have to be met. The first one is that it needs to have 3 terms. So are there any of these options that do not have 3 terms in them? No, all I see are options that have 3 terms, which means I can't eliminate any right now. So I need to start looking at the other requirements. The next requirement is that my first and third terms are both perfect squares. So let's check that. 25x squared, well, 25 is a perfect square and so is x squared, so that one's good. 1 is a perfect square, that's good. X squared is a perfect square because it's x times x. 4 is 2 times 2, so we're good there. On C, 9 is 3 times 3. X squared is x times x, so that one's good. 4 is 2 times 2. That one's also okay. We have option D. X squared is already a perfect square because it's x times x. And 49 is 7 times 7. So again, I was not able to eliminate any, which means I need to look at my next requirement. My next requirement then is that all of my perfect squares have to be positive. So as I'm looking, 25 and 1 are both positive. X and 4 are both positive. Oh, I've got a negative 9 here on C. So I can go ahead and get rid of that one because it cannot be a perfect square then. And then part D, x squared and 49 are both positive. So I was able to eliminate 1 so far. So from here, I need to verify that my middle term is twice the product of the roots of my perfect squares. Okay, so we need to do that whole thing that we did before when we were testing all of these. So I'm going to go ahead and test A and B first. Starting with A, 25x squared is 5x times 5x. 1 is 1 times 1. When I take 5x and 1 and multiply them together, I get 5x. And then I need to double that. Well, 2 times 5 is 10. So my middle term here should be a 10x. Well, what do you know? It is. So we're good to go there. Now we need to test part B. X squared is x times x. 4 is 2 times 2. I take one of each of those and multiply them together. I get 2x. Then I need to double that. Well, 2 times 2 is 4. So I should have 4x as my middle term. Uh-oh, I have 5x, which means B is no longer an option as a perfect square trinomial because my middle term was not twice the product of the roots of my perfect squares. So now we need to go ahead and we need to test part D. So x squared is x times x. (49) is 7 times 7. Multiply one of each of those together, I get 7x. I double it, and I get 14x. So I expect that my middle term there is going to be a 14x, and in fact, it is. So this one is a perfect square trinomial, which means I had two of them here. I had A and I had D. Both of those are options or are perfect square trinomials. So the next special case that we're going to look at is actually one that we've already done before. We just haven't formally looked at it. Okay, and this will be the last one that we do today. So this is case number 2, and it is called the difference of squares. An example we have is x squared minus 9. In order for this to be a difference of squares, it has to, of course, contain squares or perfect squares. So since there are only 2 terms here, I need to verify that both of them are perfect squares. So x squared we know is x times x, and 9 is 3 times 3, so we're good there. How would I factor x squared minus 9? Well, the first thing I need to do is I need to fill in that missing middle term. So I have x squared plus 0x minus 9. Then I'm looking for 2 numbers that multiply together to get a negative 9, but add to get 0. If they're adding to get 0, that means they have to be the same number with opposite signs. So I'm probably looking at 3 and negative 3. What do you know? Those work. 3 times a negative 3 is negative 9. 3 plus a negative 3 is 0. So this factors into x minus 3, x plus 3. We've done this before when we were doing factoring with our CB chart. But if we recognize that this is in fact a difference of squares, we could skip all of this and just make it x and then each of the factors that multiplies together to get negative 9. So plus 3 and minus 3. Okay, so another example of a difference of squares would be x squared minus 25. Well, I know this is a difference of squares because x squared is a perfect square and so is 25, which means since it only has 2 terms, because that has to be true for a difference of squares, it's going to factor into 1 positive and 1 negative of whatever the root is of 25. So what's the square root of 25? Well, hopefully you know that it's 5. So this will factor into x plus 5 and x minus 5. Because 5 times a negative 5 is negative 25, and 5 plus a negative 5 is 0, which is why we only have 2 terms here and we don't have that middle x term. So a difference of squares is when you have a binomial, so 2 terms, each of which is a perfect square, and it is subtraction in the middle. It only works if it's subtracting. Okay, so we couldn't have x squared plus 25. That would not work. Only x squared minus 25. Okay, or only perfect square minus a perfect square. It also only works if my first term is a square and my second term is a constant. Okay, so this only works if I have a square at the beginning and a constant on the end. Let's go ahead and do another one. I would like to do 49x squared minus 9. So we need to check, is it in fact two terms? Well, yes, it is. My first term is an x squared, so that one's good to go. And my second term is a constant, so it's just a number. Perfect. I need to make sure that each of these are perfect squares. So what multiplies together to get 49x squared? Well, to get 49, I have 7 and 7. To get x squared, I have x and x. So 7x times 7x would be 49x squared. To get to 9, I have 3 and 3, which means when this factors, it's going to factor into the root of my first term and the root of my second term twice, one with addition and one with subtraction. So this factors into 7x plus 3 and 7x minus 3. Okay, so both of my factors are identical except one is addition and one is subtraction. We have 2 more examples and I'm going to set you free for the day, or at least for my class. So a squared plus, not plus, a squared b squared minus c squared. So this one's a little bit different because I don't just have numbers, but it still follows the same rules. Okay, so I have to look at a squared b squared as all one term because it's connected by multiplication. So its factors are simply what multiplies together to get a squared and what multiplies together to get b squared. So to get a squared, I'd have a and a. To get b squared, I'd have b and b. So its square root is ab, or a times b. Then to get c squared, well, it's just going to be c times c. And then it factors exactly like this previous example. So I'm going to have 2 factors. The root of the first term goes at the beginning of both. The root of my second term goes at the end of both. One is addition and one is subtraction because it was a difference or subtraction of squares. One more and then I will let you look at your homework. So the last example we're going to do is x squared, y squared minus z squared. I would actually like you to try this one on your own. I will give you about a minute just to look at it, okay? So on my first term, which is x squared, y squared, I know to get x squared, I have to have x times x. To get y squared, I have to have y times y. So when I put them together, I have xy times xy. And then z squared is obviously z and z. This is a difference, which means it's subtraction. So I'm good to go ahead and factor this, just like I did the previous ones. The root of my first term, so xy, goes at the beginning of each. The root of my second term, which is z, goes at the end of each. One is addition and one is subtraction. So that is a difference of squares. We're going to go ahead and stop here. We will finish out our third case on tomorrow, so Tuesday. So after you go ahead and get off here, I would like for you to go ahead and take a look at the homework. There are definitely some on there that you can do. The only ones I think you can't do would be our case number 3, which are the cubes. So anything that has an exponent of 3, you're probably not ready for yet. Okay? So feel free to log off of here. I will save this recording and put it on Canvas in case you want to look back at it later. And I will stay on for the rest of class in case you have questions. Okay? Have a wonderful day, everyone.